Hi friends, welcome back to new session. In the last session, we started a characteristics of DC generator and we explained those characteristics for separately exit DC generator and shunt generator. Okay. Now in this session, we'll proceed characteristics of DC generator topic. See, first of all, for DC series generator, so I think I told you already in the last class I explained the characteristics for separate exit generator and for shunt generator also. Now I'm just proceeding for series generator and compound generator in this session. See, so let me draw first of all open circuit characteristics, then I'll go for internal characteristics, then I'll go for external characteristics. Okay. First of all, let me draw OCC. So guys, please let me first of all let me draw this series generator. We will be having armature. So here in this series generator, series field winding is connected in series with you can say load. In series load. So suppose let me have some switch here. Load. Okay. Here is but series field winding resistance RSC. Suppose I am asking a simple question here. So please try to tell me. Suppose if you take series generator, if switch is open, that means I mean to ask indirectly for DC series generator under no load condition. If the switch is open means what I can say under no load condition. So tell me, do we have buildup of voltage in this case? No. Why means see series generator comes under category of self-excited generator. I told you for self-excited generator initially some residual flux will be there. Let me do residual flux like this. Okay. So because of this residual flux, because of generator action, when a moving conductor curves this magnetic field, EMF will be induced in that conductor. Okay, because of that EMF will be having some current IA if there is closed path. But here problem is your armature or I can say field winding is connected in series with the load. If a load is open, I mean if a no, I'm just discussing about no load condition. If a load is open, if switch is open here, if there is no load, so definitely there is no closed path. I don't have any current from the generator. So if there is no IA current, if there is no ISC current, so if there is no IA current, if there is no series field winding current, so I don't have any series field flux. If there is no series field flux which is aiding your residual flux, so obviously flux will not build up, EMF will not build up. So what is the conclusion here? DC series generator will not build up voltage under no load condition. Then you may get one doubt, sir. If the DC series generator will not build up voltage under no load condition, then how you just drawn this OCC open circuit characteristics? How I just drawn, which is graph between E versus ISC. This graph how I just drawn means is simply by keeping this field winding in the circuit, no doubt I cannot draw OCC. As I told you, because of some residual flux, because of generator action, some EMF will be induced. Because of that EMF, you'll get current only under load condition. If switch is closed only, you'll get if switch is open under no load condition, I don't have any current. I don't have any series field winding current. I don't have any series flux. So flux will not build up, EMF will not build up. So by keeping this field winding in the circuit, I cannot draw OCC. So it's actually this OCC, this is nothing but these cases are imaginary cases, I can say that. So I'm just disconnecting this field winding and connecting this field winding across some small DC source, and I'm just drawing some fictitious or imaginary cases. So for this much voltage, for this much of field current, so this is a flux, this is the EMF, like that I'm just drawing this one. Okay, so guys, try to understand. OCC curve cannot be drawn by keeping field winding in the circuit. You have to disconnect that field winding and you have to connect it across a small DC source. So correspond with some field current, some flux, some EMF, like that I can draw imaginary characteristics only. Okay, so yeah, just like for DC shunt and DC separately, OCC will be like this. Though it is imaginary, you'll be having characteristics. This yellow color graph indicates OCC graph between E versus ISC. As usual, this O is the residual EMF. Okay, and this is about OCC. Now let me explain internal characteristics and external characteristics. First of all, let me explain internal characteristics. You know, guys, for DC series generator, you know, formula of KVL equation E equal to V plus IA into RA plus RSC. This everybody knows that. Now here my simple question is, as the load increases, means what? I mean to say that as load increases means your load current increases. As load current increases, what will happen to ISC and IA value increases. As IA increases, what will happen to pi A value? Armature flux increases. Okay, armature flux increases. Try to understand. So what is armature reaction means? Effect of armature flux on main flux is called armature reaction. If you observe clearly for separately as well as for shunt generator, as load increases there, IA increases, pi A increases only. There is no increment of main flux. I mean to say there is no increment of shunt flux in the shunt generator. There is an increment of main flux in separate generator. What is the reason? Because in series generator, your field winding is connected in series with load. Whereas in shunt series, I mean field winding is connected. In shunt, I mean to say shunt field winding is connected across your load, not in series with load. Okay. That's the reason why in DC series generator, as load increases, in addition to armature flux, your main flux, series flux also increases. This is not in the case of shunt, or I can say separately. So their main flux is it is not depending on load. But here, yes, main flux is connected, series field winding is connected, in series the load. As the load increases, no doubt your series flux also increases here. Okay, that is the reason why your net flux will increase here. Try to understand. So in previous case, as load increases, IA increases, pi A increases, armature reaction effect increases, I used to write DME increases, net flux will reduce, I wrote in previous case. But now I'm writing pi A net flux increase. What is the reason for that? Because very simple reason, as load increases here, in addition to armature flux, your series flux, main flux also increasing here. So that's the reason why net flux will be increasing here, EMF will be increasing. Okay, guys. So that's the reason why your internal gases will be rising like this in this manner. So let me use laser point here. Yes. So your internal gases will be rising, not drooping like in case of, if you see, in case of shunt, if you remember, I just drawn like this. See, in shunt. So if you want me to draw E versus, I can say E versus IA, there I told you on no load condition. So EMF was induced there. In case of shunt generator and no load condition, EMF was induced. That EMF only call it as E. As load increases, I told you your EMF is reducing like that. I told. Do you remember that? Okay. So I'm having drooping gases here. Okay. And this drop I wrote, it is nothing but armature reaction drop, because from no load to load, so armature reaction drop is there. No, under no load condition there is no armature reaction drop, but load condition armature reaction is there. Therefore, this will be drooping, and this drop is due to armature reaction. Is it okay? Now, but here I'm not getting a drooping, because under no load condition, tell me what is the value of EMF induced in DC series generator? Only residual EMF only. I can say only residual EMF is the only EMF induced in DC series generator under no load condition. Okay, because the main reason, field one is connected, in series the load. So though residual flux is there, though generator action will take place, though though EMF is induced, because of that EMF will get some current if there is a closed path here. But here on no load condition, there is no closed path. I won't have any current. I don't have any series flux. There is no flux buildup concept. There is no EMF field. Okay, so simply it's a residual EMF only. That's the reason why on no load condition EMF is so very is almost of zero. I can say in residual EMF this much. And as load increases, why your net flux increases means here I told you reason also. So in this series generator, in addition to pi A, your series flux, main flux is increasing. That's the reason why you are getting a rising cases here. And don't confuse here from OCC to internal. If you see, these internal cases are below OCC curve only. What's the reason for that? Anybody please try to understand. So from when compared to the OCC, internal cases will be below than OCC. Reason very simple. So tell me the example, if you take this much load, if you take at this load, if you see, if you see OCC curve, this is no load voltage. Okay. And if you see at this load, what about internal voltage means, what about this voltage? I can say this much. What is the reason for that? See, under open circuit condition, some drop is not there. Whereas under, if you see under load condition, some drop is there. What is that drop? Armature reaction. Yeah, no doubt, because of armature reaction drop is there. So here, whatever I'm writing, E is increasing means, yes, no doubt E is increasing because of net flux increasing here. But that increasing curve will be below the OCC curve only due to armature reaction drop, which is present in no load, which is present in a load condition, not present in a no load condition. Okay, guys. So that's the reason why I'm getting internal gases rising. That too from with respect to OCC. If you see internal gases, yes, you are getting somewhat below, and this drop can be taken as yes, no doubt armature reaction drop. Okay, guys. Now, what about external? It's very simple. External means a graph between V versus I can say IL. You know, V means it's a simple V equals to E minus IA into RA plus RSC. Okay, so as usual, as load increases, what will happen to IA value? IL, first of all, load current will increase, and IL and ISC, IA, everything same only in case of series generator. So IA increases. Whenever IA increases, what will happen to IA into RA plus RSC? It will increase. So whenever this value is increasing, your V will, yeah, your no, no, yeah, IA into RA plus RS is increasing, okay. And as usual, this E is increasing. Why E is increasing means I already told you, because net flux increases, that's why E is increasing, okay. So here there is no need to focus this one, just leave it. So because IA into RA plus RS is increasing here, this V will be, yeah. So try to understand, guys. When as load increases, I'm saying IA increases. So IA into RA plus RSC increases, okay. Here the problem is, some people will have a confusion. V equal to, I can say, E minus IA into RA plus RSC, okay. First of all, my question here is whether raising curve will get a drooping curve will get a. That one, that please try to understand, okay. Please try to understand. You are getting raising via or drooping via. So that means it is raising V or drooping is depending on your E, because already your E is increasing as load increasing, your E is increasing. What is the reason? Because net flux increasing. So obviously, guys, because V is increasing, your V will also will be increasing. Yes, no doubt V will be increasing here. So in that because of that reason I wrote here. Why I'm writing E is increasing means because of this concept. I'm saying that I'm writing here E is increasing. No doubt V will be increasing. But question here is, no doubt your V will be increased, no doubt in that. But that V will be below the internal gases. What is the reason for that? Because V equal to E minus IA into RA plus RS. That means from this E, you have to subtract something. From this E, you have to subtract something, then only you get V. That means your V will be E minus something. Therefore, V curve will be below the, you can say, easy curve. So this is what I can say, external curve, external gases, V versus IL. I'm getting once again rising only. And here drop means what? Easy, when with respect to easy minus this IA into RA plus RSC gives you V. Therefore, this drop is nothing but I can write IA into RA plus RSC. So once again having a rising gases. So guys, don't confuse here. Very simple reason. Some people will have confusion. Sir, you told IA into RA plus R is increasing. No, sir. This term is increasing, so V has to reduce. No, sir. Like that, they will think. No, it's not. It's not correct. What is the reason? Because when with respect to this IA into RA plus RSC, your V is mainly dominated on E value. Okay, E value. This E is increasing. Already. This is green color curve. So obviously V also will be increasing. But with respect to EZ, your V is below only because of this drop IA into RA plus RSC. You can see this equation, you can easily understand. V equal to E minus IA into RA plus RSC. So with respect to this EZ, you have to separate IA into RA plus RSC. Then only you get a V curve. Okay, guys. And one thing you have to understand. So tell me, so for DC series generator, I'm saying you're having a rising characteristics or a drooping characteristics. So you're having rising characteristics like this. You are not having a drooping like this. Okay, for shunt as well as for separate, you are having drooping characteristics. Whereas for series generator, you are having a rising characteristics. That means as load increases, your V load voltage is increasing. Load voltage is increasing. Therefore, I cannot use this DC series generator for constant voltage applications. I can use this DC series generator as a voltage booster in a DC transmission line. In HVDC transmission line, suppose a voltage drop occurs. So to compensate the drop, to boost the voltage, I'm just using this DC series generator as a voltage booster. Okay, very simple thing. And can you please tell me what is the approximate value of percentage voltage regulation of a DC series generator? So please tell me percentage voltage regulation formula. no load voltage minus full load voltage divided by full load voltage into 100. This is the formula, right? Okay, so please tell me what is the no load voltage here. You please try to see this, external characteristics. You can understand easily. Your no load voltage is almost all residual EMF, or I can say zero. You can take a residual EMF, or you can take almost a zero minus, let me take V full load as V something like that. V 0 minus V by V into 100. How much value? It approximately I can say minus 100%. No, okay. That means, see, out of all generators, like out of all DC generators, DC series generator is having highest voltage regulation magnitude. How much? I can say 100%. So to be frank, it's a minus 100%. If you are asking about magnitude, yes, it's a 100%. Okay. So please try to remember this. Okay. Yeah, I can use this as voltage booster in DC transmission because it is a rising characteristic. Right here, as voltage booster in DC transmission line. What is the reason for that? Since rising characteristics, okay guys. So this is about the DC series generator. Let me go for compound generator. Okay, see, every time there is no need to explain this OCC, because OCC will be almost all same for separately shunt, series, as well as for compound also. And internal characteristics also there is no need to explain every time, because if you draw external characteristics, so indirectly in that internal is there, no, because V equal to EZ minus something. Yes, so obviously if you draw external, that is enough for us. So now from now onwards I'll be drawing only external characteristics here. So here I wrote no load characteristics are similar to that of shunt and the series generator for compound generator also. And guys, please try to see this relation. In compound means, I told you, depending on how series field winding connected, we are having a long shunt generator is there and short shunt generator is there. I take an example here, short shunt. If you want, you can take long shunt also, nothing wrong. So here series field winding, which is connected in series with the load in case of short shunt generator, and shunt field winding here. And IA current from the generator, it is dividing as ISH and ISC. Okay, and load current means IL is load voltage V. Don't see this REX from now only. Don't see this REX now only. Just wait for some time. Let us see. If you apply KVL equation for this loop, E is equal to V plus IA RA plus ISC into RSC is the relation here. And I told, depending on the degree of compounding, compound generators are classified into two types. Number one, cumulative compound machine. Number two, differential compound machine. In a cumulative compound machine, your net flux will be what I can say, shunt flux plus series flux. No, you shunt flux plus series flux. So the both will be added up. So in a differential compound machine, net flux equals to shunt flux minus series flux. This everybody knows that. Okay, and let me go for a cumulative compound generator, and let me draw how we'll draw this external cases for cumulative compound generator. We'll see. I told you in cumulative compound generator, total main flux equals to, I can say, shunt flux plus series flux. Okay, and is equals to V plus IA RA plus ISC RSC. This relation, that is okay. And guys, please try to see, as the load increases here, as the load increases means as load current IL increases here. Tell me your ISC also increases, no, because ISC and IL is everything same only. ISC increases. And tell me guys, as ISC increases, what will happen to your flux? I mean series field flux, series flux also. ISC also increases because series field series current is flowing through series field winding. So as ISC increases, obviously ISC also will increases, no doubt in that. And as load increases, I told you, obviously current coming from this generator, IA also will be increasing, generation also will be increasing. I can say IA will be increasing and pi A will be increasing. So guys, I told you effect of armature flux and main flux called armature reaction. Whenever armature flux is increasing here, so armature reaction is increasing, demagnetizing effect also will be increasing. Yes or no? Okay. Here, my question here is, so because of demagnetizing effect, what I can here, total flux equals net flux equals to, I can say main flux minus, I can say main flux minus, you should write armature flux. But here main flux means what, I can write pi S plus pi S, because it's cumulative compound. Main flux nothing but I can say pi S plus pi S minus pi A. Why I'm writing minus pi A here? Because of this armature reaction effect. So guys, here my question is, already told as load increases, pi S increases. Okay, yes, pi S is increasing. Okay, and pi A is also increasing. Pi A is also increasing. So please tell me, if pi S increasing, pi A also increasing, tell me, can you decide variation of your net flux here? No, because if pi S is more dominated, so I may say that pi N is increasing. If pi A is more dominated, I may say that pi N is reducing. But it's not. I cannot justify variation of net flux here. Variation of net flux cannot be decided here. So for that, what I am doing in a cumulative compound generator, what I am doing, simply I'm just connecting some variable resistance Rex across series field winding like this. Okay. So by connecting a variable resistor Rex across the series field winding, cumulative compound generator can be used as over compound generator, under compound generator, and a flat or level compound generator. Let us see how by varying this variable resistance which is connected across series field winding, how I'll be using a cumulative compound generator as over compound, under compound, and flat compound. We'll see. So guys, let us see in this first of all over compound generator. So very simple. In over compound generator case, by varying this variable resistor Rex, okay, let me use laser point here. By varying this variable resistance Rex, I'll maintain such that series field winding MMF is more than armature MMF. Like that, I'll vary. So by varying this Rex, I'll see such that NSCIS means what, series field winding MMF is more than armature MMF, NAIA. So because whenever series field MMF is more than armature MMF, so obviously flux is because of MMF only. No? So whenever series field winding MMF is more than armature MMF, so obviously series flux will be more than armature flux. Okay. So guys, whenever pi s is more than pi a, so now tell me pi s is more than pi a. So pi s is more dominant here. So net flux will increase because pi is increasing here. Your net flux also will increase. So yes, net flux will be increasing here. So whenever net flux increasing, EZ will be increasing. What will happen to your load voltage also will be increasing. So that's the reason why if you see over compound generator, you are having a rising of V characteristic. And you may get one doubt, sir, why you are saying under no load condition, how can you say that EMF, some limited value of EMF, I mean to say that under no load condition, how can you say that EMF E is there? Very simple. See, under no load means, let me open this, let me open this, no load condition means, let me open the series field winding, or I guess let me open this one. So guys, at that time, your machine is acting as what? Shunt generator under no load condition. We already know shunt generator, if you say, if you take under no load condition, EMF will build up. So that's the reason, yes, EMF will build up. Yes, E is there here. So try to understand, guys. If you take a short shunt compound generator under no load condition, so series field winding became a dummy here because it's open. There is no current through series field winding. So your machine acting as what I can say, shunt field winding is there, which is cut across armature under no load condition. So obviously it's just like shunt generator under no load condition. Yes, shunt generator will induce EMF under no load condition. If you want, you can refer that DC shunt generator. I explained there. So guys, that's why I just showed here EMF value, E value, and no load value, no load voltage. I just took it as E value. As load increases, I'm just getting V value is increasing. So that's the reason I'm just getting this raising characteristics of your V for over compound. So which indicated with the yellow color. Okay, guys. And what about for under compound generator? So once again, by varying this variable ratios, I'll adjust such that your armature MMF, NAIA will be more than NSCISC, or I guess NSCISC is less than NAIA, like that I'll maintain. So what will happen because of that? Your series flux will be less than armature flux. So whenever armature flux is more dominated here, yes, whenever pi is more dominated, you tell me minus m is more dominated, your net flux will reduce. Yes, net flux will reduce, EZ will reduce, your V will reduce. That's why for under compound, I just used this green color. I just assumed for under compound also, no load voltage is E only, your variation of your V is reducing. That's why you're having curve like this. Just like a shunt, and separately you're having drooping characteristics we are getting here. Okay guys, let me take a flat compound generator. So where, try to see for flat compound generator, by varying this variable relations REF, I'll maintain such that NSCISC is equals to NEIA. That means series field winding MMF is equals to armature MMF. Like that I'll maintain. So at that time pi SC equals to pi, this pi SC and pi A will be equal. This will be down, cancelled with each other. Once again net flux will be pi SH only. Here one thing you have to understand. What is that? See, under no load condition, I told you only shunt flux is there here. That means EMF is correspond to shunt flux. So that EMF one I call it as E. And what I'm doing here under full load condition, I just maintained pi SC equal to pi A value by keeping NSC IS equals to NAIA, pi S equals to pi A. So pi S and pi A will cancel with each other. Once again, your net flux is the shunt flux here. That means EMF is correspond to shunt flux. And no load condition also EMF is correspond to shunt flux E. And full load condition also EMF is correspond to shunt flux E only. This is no load EMF E. And at full load also for flat compound, I just used blue color. Yeah, full load condition also I'm getting EMF once again E only. Okay, so no load voltage, full load voltage, same only here. But in between no load to full load, what's happening here? Your curve is increasing and it is coming back to once again E value. So that means what? In this region, I just maintained pi AC more than pi A. Whenever pi AC is more than pi A, your net flux will increase. Your V will be increasing here. So once again, it will come back like this. Okay, so there is no need to bother about between no load to full load. Okay, so at a full load condition, yes, your pi s and pi a will be equal, net flux equals to shunt flux, so your EMF is just like E only. So here one thing you have to remember, so your no load voltage and full load voltage are same under for flat compound or level compound generator. That is very important. And in between, from between no load to full load, your curve is increasing, and here it is coming back to yes E value also. Okay, please try to remember this graph so that it will be useful for so many examinations to solve for solving some questions. Okay, right here. So please let me ask some simple questions here. I think I explained over compound, flat compound, under compound. So please tell me percentage voltage regulation for I am asking for compound. See, no load voltage. I told you no load voltage means what? E. No load voltage E minus full load voltage means for over compound, full load voltage is this much. Okay, this much. Let me take it as V. Okay, no load minus full load by full load into 100. So it's a common sense that for over compound generator, your full load voltage is more than no load voltage. Your V is more than E value. So E is less here, whereas V is more. So percentage voltage is for over compound is what I'm saying, negative or positive. You are getting negative value. You are getting a negative value. So guys, for over compound generator also you are having a rising characteristics. That's the reason over compound generator also, just like a series generator, whatever I explained previous thing here. So since the series generator is having rising characteristics, it can be used as a voltage booster. So over compound generator also having rising characteristics, you can use over compound generator as a voltage booster. Okay, and percentage voltage regulation, why it is negative means yes, full load voltage more than no load voltage. That's the reason we are getting negative value here. And for under compound, just like shunt generator and separate generator, so no load voltage means E minus full load voltage means V by V into 100. So yeah, what is the full load voltage for under compound? This much. I can take it as V value. So obviously your full load voltage is less than no load voltage, your V is less than E is more. So obviously percentage voltage regulation for I can say under compound. It's not over compound, it's under compound. For under compound, it's what I can say positive. Okay, positive. And what about for flat compound generator? So here very one thing is very important. I can say here for flat compound generator, I can write here at a full load condition, percentage voltage regulation for flat compound or level compound generator is how much? 0. Why? You know formula, percentage voltage is equals to no load voltage means E here, full load voltage once again you get E only, E minus E by full load voltage E into 100. So how much you are getting here? 0 only, no? Yes, that's the reason. And guys, one thing which is very very important for flat compound generator, suppose if they ask you question at full load condition, your answer is 0, no doubt in that. Suppose if they ask question at at other than full load, example at 30% load, 40% load, 50% load, 60% load, something like that. Example, let me take 50% load. Okay, if he's asking what is the percentage voltage regulation for flat compound or level compound generator at a 50% load, means at that time your no load voltage is E only, but your full load voltage is what? This much. So where V is more than E. So at that time, what is the percentage voltage regulation for a flat compound generator at 50% load? It's a negative. So I can write here for at 50, not at 50, I'm saying at other than full load. You can take 30, 40, 50, something like that. Okay. You can take the 20, 10%, 20%, 30%, 40%, 50%, 60%, 70%, 80%, something like that. At other than full load, if you take at any load, example I have taken 50% load, at 50% load, percentage voltage regulation is what I can say, guys, negative or positive? Negative. Because your 50% load voltage V is more than no load voltage E, therefore definitely you'll get a percentage voltage regulation negative value. Be careful in examination what is asking. Depending on the question you have to react. Suppose if they want to ask question at 20, 30, 40, 50, 60, 70% loads, definitely they will mention. If they won't mention, you please take it as a question is asking at a full load, then you can go for option 0%. Okay. Suppose if they ask you specifically 20%, 30%, 50%, something like that, your answer will be negative, not at 0. Okay. So please be careful. That is regarding flat compound or level compound generator. See guys, if you see over compound generator, because it is having rising characteristics, it can be used as voltage booster. And if you see under compound, it is having a drooping characteristics just like a separated and shunt. That's the reason under compound generator can be used as a constant voltage generator. That means whatever the applications I told for separated and shunt, those applications will be valid for under compound also. To be frank, not only for under compound, it is applicable for flat compound also, because from no load to full load there is no difference in voltage, no, so almost the same voltage. Therefore flat compound, under compound applications are similar to separately and shunt generators. Okay, next guys, very important, what about differential components? This is very important. I told you guys differential compound generator also comes under long shunt or short shunt, your wish. I had taken example once again, short shunt. In short shunt, you know formula E equal to V plus IERA plus ISC RSC. And you know in differential compound generator guys, I mean main flux equals to what I can write, pi SH minus pi SC. Everybody knows that pi SH minus pi SC. Here my question is, as load increases, tell me guys, that means IL increases. Try to see this figure. Okay, this circuit should be in your mind. Every time there is no need to draw. As load increases, IL increases, IS increases, pi SC. So, I mean series flux also will be increases. Right? Yeah, series flux increases. And as the load increases, so current coming from the generator, I mean to say armature current also increases. Yes, IA increases here. Armature flux increases. Okay, armature reaction increases. GME increases. Demagnetizing effect increases. So here I can justify variation of net flux, but in cumulative I cannot justify here. Very simple reason, because here pi n equal to pi sh plus pi sc minus pi a. Here for pi sc plus symbol is there, for pi a minus symbol is there. So one is increasing and another is pi s is increasing, pi a is also increasing, but one for one it is positive, for one it is, for another it is negative. So I cannot justify the variation of your pi n, but here I can say the variation of pi n. Why? Your main flux means I can say, yes, you know, because of net flux becomes what I can say, main flux minus armature flux. Why I'm writing minus here? Because of DM effect. Okay. So here main flux means what? Shunt flux minus series flux in differential compound. Minus pi is there. Already pi is increasing. Okay. And pi sc also increasing. So both, see, this is increasing, this is increasing. So that means what? Two negative terms are increasing. Try to understand. Two negative terms are increasing. So obviously, what will happen to your net flux, guys? Net flux will reduce. It's not reducing. It reduces very large. So don't say simply reducing. Reduces by very large amount. What is the reason? Because two negative terms are there here. So both are increasing. So obviously, pi n will reduce a lot. Whenever pi n will reduce a lot, EZ will reduce a lot, V will reduce a lot. So EZ comma V reduces by very large amount. Okay, guys. And once again for differential compound also, I take a no load voltage Z once again here. Okay, and I'm just saying that as load increases, what is the conclusion you are getting here? Your load voltage increase reducing by very large amount. That's the reason. Yes, see, try to see this. You know, this color, I can say violet color. So your V is reducing by very large amount. See, this much, very, your node voltage this much means full load voltage very less. See, full load voltage is almost or very less. This is the value. It's very less, no, very less value. Okay. Okay, this is what differential, I can say, compound, differential compound generator. Okay, guys. So from external characteristics of a differential compound generator, what is the conclusion you just got? Very simple. So at a full load condition, you are having, voltage less, but current is large, no? Because full load means current is large. I is more, but whereas voltage is less here. So try to understand from external characteristics of your differential compound generator, what is the conclusion I'm getting here? So differential compound generator is having a large current, small voltage characteristics, which are which are necessary for arc welding applications. That's why differential compound generator will be used for arc welding applications, because it is having arc welding application. I mean, so arc welding, for welding applications I need a large current comma low voltage, that we are getting from differential compound generator. So obviously I can use differential compound generator for welding applications. Okay guys. And one more thing. So tell me, what is the percentage voltage regulation for differential compound generator? No load voltage means what? Is E value, E minus, I mean no load voltage minus full load voltage means this value, V by V into 100. Try to understand your no doubt full load voltage is less than E. To be frank, this V is very less, no? V, I mean V is, I can say very small amount. I can say V is a very small, very less value, very less value. Very less value means, very less value means, so tell me first of all my question, my answer to my question. So please tell me, what is the percentage voltage regulation for differential compound? Is it a positive or negative? First question I'm asking. Is it a positive or negative? For a percentage voltage regulation for differential compound I'm asking, it definitely is positive. This is positive. That too, your V is very less value. Therefore, obviously, your voltage regulation value will be more. So I can say percentage voltage regulation for a differential compound generator will be large positive value, large positive value. Okay. So guys, this is very important. Okay, try to understand. So they may ask you some questions. Out of all the generators, tell me which DC generator is having highest positive voltage regulation value. For which generator it is having highest positive voltage regulation value means obviously your option is differential compound generator. If they won't mention positive word, if they ask question, out of all the DC generators, tell me which generator is having highest voltage regulation magnitude means your answer is DC series generator, because there how much answer we are getting? I can say here 100% no, minus 100% no, friends, minus 100% no. So your answer is 100 minus 100% is there. If they won't mention positive or negative, so if they ask simply magnitude, your answer is DC series generator. If they ask positive, I mean which generator is having highest positive voltage regulation magnitude means obviously your answer is a differential compound generator. Okay guys. So this for over compound, flat compound, under compound, differential compound. So do one thing. So since external characteristics is very important for examination point of view, I'll do one thing. I'll draw external characteristics V versus IL for all the generators in one in one graph only. See, that too I'm assuming for all generators, no load voltage I'll assume it as E. Okay, so if no load voltage is no load voltage is taken as the same, what of that value E for all generators, for all DC generators except DC series generator. What is the reason? You know, for DC series generator, what is the value of no load voltage? It's a 0, or I can say residual EMF, very less value, except DC series generator. So then external characteristics for all DC generators are as follows. Okay, so I think just before, I mean, in the here now only explained OC. I mean, for over compound, for flat compound, for under compound, for differential compound explained. So OC, flat compound, under compound, differential compound explained here. It's a differential. It's not visible. Please try to write. This color is not visible. Differential. It's a differential. It's a differential compound. Okay. And I already explained shunt and separately. I told you in shunt, yeah, voltage drop is more than separately. That's why your curve will be somewhat below the separate excited curve. So separately and shunt here. If you want, you can include a series generator also. So for that, let me use some of the different color. Yes. So I told you for series generator under no load condition, what is the voltage? I said, and what is the no load voltage? What is the no load voltage for this series generator? Almost 0, or I can say residual EMF. Okay. So what? Let me take this one. This small value. And as load increase, I told you you are going to have rising characteristics like this. You are going to have rising characteristics. This is for series generator. Okay. So I just explained, I just drawn V versus IL characteristics for all the generators in one graph. Okay. Okay guys, I think this one I already explained. Out of all generators, which generator is having least voltage regulation means, I told you answer flat compound generator. So what is the reason here? I told you already. For flat compound at indirect at full load condition, no load voltage is E, at full load condition voltage is E. Once again, your voltage regulation value, how much I told here? It's 0, right? 0. That's why out of all DC generators, I mean generator which is having least voltage regulation value means flat compound generator or I guess level compound generator, your answer is 0%. Okay. And out of all generators, which generator is having highest voltage regulation means if he is asking answer highest voltage regulation means he is not including, he is not saying positive or negative, simply is asking out of all generators which generator is having highest voltage regulation means. So your answer is series generator. What is the answer? What is the value? Minus 100%. Since minus 100% is the value, therefore you should go for option series generator. Suppose if they ask you highest positive voltage regulation, then your answer will be differential compound. Just now I told you in the previous study, large volt positive voltage regulation means it's for differential compound. Okay. So highest positive voltage regulation will be there for differential compound generator. And as usual, for over compound generator, voltage regulation is I can say negative. For under compound, it is a positive. Okay. For separate excited, it is a positive once again. For shunt, it is a positive. Okay, guys. And let us see applications. I told you flat compound, you can take under compound, you can take applications are similar to the top of separately and shunt, which I explained in separately excited generator and shunt generator cat 6. If you want, you can refer there. So I think application I told you as you can use those separately or shunt. In fact, you can use flat compound or under compound also as constant voltage sources, auxiliary power supplies, battery charging using constant voltage method for lighting purpose as an exciter to excite the synchronous motion. These things I explained there. So same thing, just repeating here. And for over compound also I told because the generator which is having rising characteristics, that particular generator can be used as voltage booster in a DC transmission line. So already I told you you can use DC series generator also as a voltage booster. And in addition to that, over compound also I can use it as a voltage booster because these two generators are having rising characteristics. Okay. And what about differential compound generator? It can be used in arc welding applications. What is the reason? Because arc welding applications requires large current, small voltage, which I got from if you see external characteristics of your differential compound generator, yes. See what is the full load voltage here? What is the full load voltage? This much, very less value here. It's very less value. And what is the current here? So at this point, voltage is very less. Okay. And what about current? Current is large. No, current is less. That's the reason why differential compound generator can be used for arc welding applications where it requires a large current, small voltage. Okay, guys. So this is about characteristics of different DC generators. Okay, and in the next video we'll explain. We'll show. I'll write EMF equation for DC generator, and for DC motor also. I'll try to see this N proportional EB by relation, and I'll get a torque equation also. From that, T proportional to pi into IA, one important relation is there. These two are very important for DC motor. N proportional EB pi and T proportional to pi into IA. So by using these two things, once again I'll start characteristics of DC motors. First of all, for shunt motor, series motor, cumulative, differential, like that will explain. Okay, and so this is for this session. Okay, and in the next session we'll explain this topic and we'll proceed to characteristics of DC motors. Okay, guys, thank you.